Today's lesson is 12.1a, adding and subtracting with radicals. Now the goal for the whole 12.1 lesson, including part B, is to add, subtract, and multiply with radicals. So multiplying with radicals will have its own video. So talking about adding. In order to add, right, for an example, 4 square root of 7 plus 9 square root of 7, for us to be able to add things together, they need to have the same square roots. So in this case, 7 needs to match for us to be added. And then once we have those same square roots, how does it add, right? Then we'd be adding just like this was 4x plus 9x, right? I did the example 3x plus 4x, but we have 4 root 7 plus 9 root 7. We're going to add 4 and 9, right? We need the square roots to match to do this. If they don't match, right, if these numbers don't match, then it's a no-go. We're just gonna rewrite it. But in this case, they do match, so we're going to do 4 plus 9. And clearly, as you've done some of this math before, 4 plus 9, you can do this without showing much work. 4 plus 9 is 13, and then we have 13 what? 13 square root of 7 is our final answer. Now, the other question would be, what if we have different roots, right? For example, 12 square root of 2 minus 7 square root of 3. Now, it is a minus. We could call this plus a negative 7 square root of 3, right? Just as a reminder on how subtraction works. Same thing as adding, we just flip the sign, right? And square root of 2, square root of 3 does not match. We can't do anything here. So what we're going to do is we just rewrite it. Our answer is, that was the answer. We couldn't simplify. 12 square root of 2 minus 7 square root of 3 would be your answer. Moving on, we've got next, and they all typically won't say solve, it will say simplify. So if we can simplify, we're going to simplify. So we've got 9 root 5 minus 7 root 5. And again, kind of color coding it here. Do these match? Is the first question you ask. And once we see yes, now we're dealing with the numbers in front. 9 minus 7, right? We're taking the sign with it. So it's 9 minus 7? 2, and then the square root of 5 comes with as the answer. So 2 square root of 5 is our final answer. This is multiplying, not adding. Next, we got 10 square root of 15 minus 3 square root of 15. Same thing. Do these match? Yes. And again, some of you will say, this is kind of a little bit of a tedious step over here. You don't need to do this step. It is pretty short for solving. We will get to some in a couple questions that are a little bit longer. So for those who are up for that challenge, you can skip ahead, but just be patient. Yep, 10 minus 3 is 7, square root of 15. That is fine if that was all your work. But just to show you, where did 7 come from? It was 10 minus 3, once these underlined match. If they don't match, then we're done, right? So next, 12 square root of 7 plus 5 square root of 7. Does it match? And on your own, try these on your own. We're kind of doing these patterns. It doesn't match. And yes, 12 and we got 7 and 7, pardon me, match. 12 plus 5 is 17 square root of 7. Next is square root of 6 and square root of 6 match. Again, yep, these match. So 9 minus 12. If I have 9 and I owe $12, I'm still going to owe 3 of the square root of 6. Next, here's where it gets a little more complicated. Sometimes our numbers won't be simplified, so we'll need to simplify first. Now, generally speaking, one of the numbers will typically look nice, the other one will need a little bit of work. So in this case, 2, we can't break it down anymore, but 12, we can. Originally, you'd say, oh, doesn't match, you know, it's not going to happen. But we need to simplify 12 first before we can say that they don't match. Now, try to remember, how do we simplify a square root? You could either look for a perfect square that goes into 12, but then you'd have to remember all those, you know, 4, 9, 16, 25, 36, and so on, and that can be a bit much. So how I like to do it is break down the prime factor tree. What numbers go into 12? Well, 2 times 6 or 3 times 4. So 2 times 6 is 12, and then 6 is 2 times 3. And then I circle the ones that are the same. Up, we have a pair of 2's. So one of the 2's is coming out. That's what the arrow is for. And that 2 is going to come out right next to the 3. It doesn't make it 3 plus 2. It doesn't make it 32. It comes out and multiplies, because right now these are multiplying. And when we simplify this square root of 12, we get 2 square root of 3. The leftover piece goes back under. So this becomes 3 times 2 square root of 3, and then plus 7 root 2. Well, 3 times 2 is 6. and 7 is still there. And now we see, does it match? Square root of 3, square root of 2 doesn't match. Because we worked to get to this point, that's our answer, right? But if that was the original question, we'd have to rewrite it, right? So that's our final answer, 6 root 3 plus 7 root 2. And well, why couldn't we rewrite the original? Might be a decent question. We need to simplify either way. The instruction says simplify, and this isn't simplified yet, so this was the correct process. Next, we've got negative 5 root 2 plus 3 root 8, right? What numbers multiply to go into 8? We've got 2 and 4 is the only set, and then 4 is 2 times 2. So I have 1, 2, 3 2s, and generally I like to circle a pair. So you just pick which two. It doesn't matter which two. I'll pick these two twos, circled. So one of them is going to come out. And then the leftover one here, this other one, is going to go back under. So one of the two is going to go right next to this 3. And this side's staying there. Negative 5 root 2 didn't change, came down. But now we have 3 times 2, square root of 2. And we have a match, right? Square root of 2, square root of 2, match. And so we're going to do the math. 3 times 2 is 6. 6 minus 5 is 1. So I get 1 square root of 2, or we just write that as square root of 2. Okay. Next up, we have 8 root 6 minus 2 square root of 24. If you feel like you're getting the pattern, feel free to pause it and try it yourself and check your answers. If not, that's all right. And going. Which one can we simplify? 6 or 24? Because clearly something looks like we need to do some work here. 24 is a bigger number, so we're going to break that one apart. You could do 2 and 12, 3 and 8, 4 and 6. Plenty of different ways. I chose 4 and 6. 4 is 2 times 2, 6 is 2 times 3, and now I'm circling my pairs. So again, I got a pair here, we got a 2 here, and a 2 here. So one of those two is going to go away. I don't have a perfect match over here. So that 1, 2 is going to come here right next to the 2, negative 2. And the 8 root 6 is just going to come on down. So now I'm going to have 2 times negative 2, square root of 6, right? 2 times 3 is 6. And what do you know? We do have that match again here. So then I'm doing the math. 8 minus 2 times 2, so 8 minus 4 is 4. And 4 root 6. Okay, notice these root 6's never cancel, just like x. We're only dealing mathematically with the front term, typically, the coefficient of those numbers. Next, 2 root 16 plus 8 root 5. So 8 root 5 comes down. Square root of 16 is 4. That is one where I expect you to have it memorized. If not, you may need to go back and look at those notes from an earlier chapter where we did the square roots. But 4, 9, 16, 25, those perfect squares, I'm typically not going to make a tree for. If you did, you would get 2 2's would come out to get 4. But now we got 2 times 4 is 8. 8 plus 8 square root of 5. Nothing's going to cancel because this doesn't have a square root. This one does. And that's our final answer. Right? Still simplified, but we didn't necessarily have something we could add together. And one last set. Again, try this on your own if you're getting the pattern. Pause the video. And continuing on, square root of 12 is 4 times 3. 4 is 2 times 2. So kind of circling my pair. We got a 2 here and a 2 here. So one of those is going to come out. We're going to get negative 4 times 2, which is minus 8. And then checking, do we have a match? 3, 3, we do have a match, so keep going. 3 minus 8 is negative 5, square root of 3. And one more, this one has 2 need to simplify. 4 is a perfect square, so we get 2. 8 is 2 times 4, which is also 2 times 2, so 2 times 2 times 2 is 8. And then again, that's just a little reminder that if you're not sure if your tree is right, multiply the bottom of each final branch, not this branch, but final branch, final branch, final branch. 3 times 2 times 2 should equal what you had originally under your square root. Same thing here, 2 times 2, 4, times 2, 8, up and matched. Taking a pair out, we got 1, 2 here, and another 2 here, and so we got 1 left over. I have to move that last circle. 1 left over, that one's going to go back underneath, but 1, 2 is going to come out next to that, negative 5. 3 times 2 is 6. Negative 5 times 2 is negative 10. We don't have a root over here, so we're just going to multiply, and we're done. 6 minus 10, square root of 2. And feel free to leave me any messages or comments if you have any questions on the material.